Hi everyone, good to see you all again. While people are still just joining, I'll just get my bit out of the way. Is there seeing lots of familiar names down there on the participants again? Is there can someone let me know through chat if they haven't been here before, so I can just run through a couple of things, or otherwise just presume you've all attended previous sessions on here.
Hi, Richard. Just a quick thing while you're chatting. I'm just putting in the link into the chat to the video that Ollie would like people to watch because they can't click on the PDF version that's on the big screen. So I just put it there.
Oh, thanks. Brilliant. Yeah, basically, he's going to be using some Tinkercad software, and you'll see there on the welcome slide and in the chat just a link to a kind of video about how to download it, basically. So that might be useful. Brilliant. Thanks. Who was that saying they've already downloaded it? Oh, Samuel. Well done, Samuel. Great stuff. There we go. And pestering you all again. If anyone hasn't done so, if you could please fill out the online form, that would be much appreciated. And it really helps us just to kind of know a little bit about you all on the session here. Though obviously there'll be no private details in it, like your names or email addresses or anything. So don't worry about that. So presumably that means that there's no one here who hasn't been before, so you don't need to hear all the stuff about mics being muted and stuff. Just in case there is anyone, please do. I mean, your mics are muted by default, but if anything happens, if you could just keep them switched off, that would be much appreciated, just so that we don't get any kind of background noises and things, disturbing stuff. And also, please, no one, of course, has done anything like it so far. But nothing offensive in the chat, if that's all right. Basically, today we have Oli Howson here. Without much further ado, I'll hand over. Actually, one thing, sorry, if I may just say it while we're all here. I did say it yesterday after the session, but many apologies from us. But we've had a cancellation on the Monday session, so I really apologise for that. Basically, it was Alina, who was going to be with a bunch of I think 16-year-olds, teenagers, anyone who recently won a Teens in AI challenge, and we're going to talk about how they came up with their idea. And sadly, they've been told they have to do some exams that afternoon. So we're really sorry about that. But after we had, it was seems we all quite enjoyed being in the breakout groups and things yesterday. What we're going to do on Monday, please do take the day off, obviously, if you want. But otherwise, we're just going to leave the portal open from 2 to 3. And if anyone does want to come along just to kind of chat amongst themselves about their idea, please do. Michael and I will be here in the background. We're not, well, Michael is more than me, but we're not IoT experts at all. So might not be able to answer too many of your more technical questions. That would be for when we are going to have lots of people available to answer those kind of questions. But it will be available anyway for you to chat amongst each other, and it will be in the background if you need any help. So without further ado, over to Oli.
Thank you very much. Right, I'm just going to share my screen and hopefully get started. So we're going to there. Okay, there we go. So, good afternoon, everyone. My name's Oli. Nice to meet you all. So, I'm going to lead you through a session working with the Arduino. It's the first of 2 sessions, so hopefully you'll all join me again next week. So, first of all, what we're going to do, first of all, we're going to have a little bit of an introduction, and I'm going to just take you through some of the lessons I've learned about playing with the Arduino and IoT in general. The majority of today is going to be a practical session, which I understand is relatively new for the other sessions, but I wanted to actually have a play and start learning how to do some things. And then be a discussion at the end, opportunity for you guys to share your own thoughts and your own feelings about it. And then a tiny bit of homework, hopefully not too hard work, prior to the second session. So I apologise in advance. Actually, I'm sat in a garage at the moment. It's 33 degrees Celsius, so If at any point I appear to be gasping, it's probably because I am. If I go quiet, if someone could just call the paramedics, that'd be fantastic. So who am I? My name's Oli. My handle on Twitter, which I use sometimes, is Mr. Howson with an underscore. And the reason I seem a bit formal there is actually I now lecture at the Open University in computer and communications. But up until a year and a half ago, I was a secondary computer science teacher. So I taught computer science to 11 to 18-year-olds. And it's still my passion is to share the enjoyment I get from fiddling with computer systems and sharing that with other people. So my links with IoT is that I don't really class myself as a maker. I'm more of a fiddler and a tinkerer. And I say it because I don't always finish my projects. I tend to end up with which works, and it does the geeky bits where I've got wires together and you can press buttons and make things flash. And I'm not really bothered about making it look pretty, putting a case around it or anything else. I love fiddling with wires and cables and microprocessors and just seeing what you can do. So first of all, what is an Arduino? Now I understand that those of you who've been in the previous sessions have had an introduction of a range of devices you can use with IoT. But can we just, because I feel like I'm doing a lot of talking and there's going to be more of that later on. So really quickly, 10 seconds in the chat window, could people just write in there what you think an Arduino is for me as succinctly as possible? Smash, got my first answer from Samuel. Arduino's a microcontroller, small controller board, a way of programming microcontroller. That's actually a really interesting thing, Tom. I'm going to mention that in a moment. Ethan, definitely, it is fantastically awesome. I'm absolutely in love with these things at the moment. Okay, so a microcontroller is a tiny, tiny little powered computer on chip. They've actually been around since the 1960s. And the Arduino came out in around, the project started in about 2005. It was a university-led project where they identified that the things they were using at university were too expensive and too clunky for the students to have one. So was it Norwegian or no, it was an Italian or Spanish university. They basically developed something new to do, and I thought that's a great reason to happen. It's based on what we call the 18 mega microcontroller. It's got all the extra bits you need on there to actually be able to deal with it. So I've got an Arduino Uno in front of me at the moment. It's got some capacitors, it's got some extra little subsystems, some resistors, etc. It's got the way of managing the power so you don't blow it up too easy. But it's really interesting what Tom said there as a way of programming a microcontroller. Because I've just started playing with a new idea that I'm developing for a computer science A-level project, really, that I want to be able to share with A-level students. And it's using these tiny little things called 80 tiny 85s. And they're tiny little chips that have only got 8 pins on. And the thing is, they haven't got the Arduino software on them. They haven't got the bootloader, so you can't just plug your computer in and go. It hasn't got a USB socket. So you can actually use an Arduino. I'm using an Arduino Uno for this. And you can connect it to the microcontroller, the AT Tiny, and you can program it with an Arduino. So it's a really, really powerful bit of kit. And quite cheap as well. So a few people that I've talked about said, well, why don't you just use a Raspberry Pi? And I'm sure that the majority of you have heard of Raspberry Pis. The thing is with Raspberry Pis, and they're fantastic. I pre-ordered one when they first came out. And I think they're absolutely fantastic. But they're bigger than the Arduino. So a Raspberry Pi is, what's that, about 5 square, whereas a big Arduino is 2.5 inches. So the size is a bit different. The Raspberry Pi also is very powerful comparatively, so it uses a lot of electricity. The things about IoT is it's about things. It's about getting things to do stuff for us, and those things can be really, really small. So it's not as powerful as Raspberry Pi. It's not got as much connectivity as Raspberry Pi, but it's something you can often run off a battery, and you can stick it inside things, which makes it really, really flexible. So today, I skipped 2 things ahead there. Today we're going to be doing a practical activity. We're going to build a little light sensor, and it's going to sense light and light an LED up. just to get learning how to actually put things together and start taking some of our ideas and concepts and building something from it. The problem is, of course, we're going to have to use an emulator. And the reason for that is, although the Arduinos are cheap, and okay, there is only 30 odd of you, getting an Arduino out to all of you, delivered with all the extra wires and things you need, wouldn't really be working very well for us. Things would go wrong, and they can be a bit finicky. Sometimes you plug them into a computer and they just don't want to talk to the computer. So we're going to use an emulator. So that way we're all starting from the same place. What it does mean, and this is the really sad bit for me, is the emulator doesn't connect to the internet, in that you can't make it go off and access other servers and transmit data and things. So it's all locked in within that emulator. So we're going to be doing IoT without the I, really, which is a bit of a shame, but it's also, you know, a lot of what we're doing, sometimes communicating with the internet is relatively simple. It's the devices that we're developing which is important. So what I'm doing to do is talk about the internet thing, because I've only recently learned some of this stuff. And I learned this actually as a workshop I went to with the Open University, and the guy had made these incredible little devices, and they're now placed all around Birmingham for measuring road temperatures. And these tiny little IoT devices, they're a few pounds each, and they've changed the way that they do the road gritting in Birmingham, and they've saved thousands and thousands and thousands of pounds. So I started learning about this. It's what makes IoT really exciting is being able to communicate with things. Yeah, I'm going to get you guys to really quickly in the chat for 10 seconds, just write what technologies could an IoT device use to connect to the internet. You know, how could you connect to another device? And I'll give you a clue. The first one that came to mind for me was Ethernet, was a network cable. So what other technologies do you guys that are listening know that an IoT device could use to connect to another thing? Wi-Fi, fantastic. Bluetooth keys, thank you. LAN, so LAN could be Wi-Fi, could be Ethernet. NFC and Bluetooth from Dan, they're very, very common. Serial ports, I missed that off my list, but good, thank you. I2C, Zigbee, I'm seeing more things than I've even thought of putting. So, for device-to-device communication. So I mean, I didn't come from an exhaustive list, but I've put a few things down. Infrared, Emma, thank you, fantastic, because I suggested that. My colleague said, no, you don't need to mention infrared. I think it's important. Wires are the simplest, of course, for Robert and Aaron. So the first one I came from was Ethernet. Plug a cable in, and it works. It's fast. It's simple. It's actually relatively cheap to do. The problem you've got, of course, is that they need to be plugged in. So if you've got a radio things, thank you, Patricia. Obviously, if you've got Ethernet, then you've got to be plugged in. If you've got an IoT kettle, you don't have to unplug your Ethernet cable every time. So, but it's a really simple way. And if you're developing, it can be a good way to test the concept. Next one I came up with was infrared. Infrared, it's relatively low power. If you think about your remote control of your TV, that's infrared. But it is line of sight. It is slow. RFID is I'm sure you've all heard of it these days. The idea of having a tag you can wave near things and it reads. It can be passive or active. It's got a lot of fantastic opportunity there. Relatively low amount of data and very, very low distance. Yes, you're right, Sam. They did. Things have moved on a little bit though. I think USB might be dying a death in some respects. So Patricia mentioned radio. So the microbits, which you've either seen or will be seeing, have got radio communication. And of course, anyone that's played with any remote control airplanes will know how useful radio communication can be. It is relatively low power unless you're going to have a massive aerial attached to your roof. It's relatively low distance, and you can put more power into it, but then you've got different kinds of costs and different kinds of issues. Bluetooth, which a lot of you mentioned, Bluetooth is an incredible thing. It was first developed, I think, around about just before the turn of the millennium. I remember seeing a white paper when I was at university and thinking, God, that's incredible, what an opportunity. It's lower distance than Wi-Fi. It's not quite as, it uses less power. It's slower than Wi-Fi. To give you an idea, the Wi-Fi in your home is probably 54 megabits. Bluetooth is around about 3 megabits. So the amount of data you can transfer, the speed you can do it isn't as much, but in some ways it's also a lot more flexible. We also got something called Bluetooth low, I think it's low energy you refer to. It's lower power, lower bandwidth, lower speed. It's not suitable for real-time communication, but it uses a lot less power. So if you're talking about these little devices that you want to make, and some of the things that I've been developing are an inch square, then saving your battery power is really, really important. We talked. It's a global standard. Everyone's got Wi-Fi these days, but it's fast, but it uses a lot of power. It's very complex. It can also be quite a bit of a pain to get up and running. So it's got pros and cons like everything else. Cellular data, same as your mobile phone, can be quite high speed. 5G, as I'm sure you're aware, is very, very high speed. It doesn't use a lot of power, but the cost can be amazing. And I read a story recently about there was I think it was a Russian group of researchers, and they were tracking eagles, and they put the cellular tracker on the back of this eagle. And the problem they had was, as the eagle was flying down towards China, it was across a number of countries, including places like Kazakhstan, and it very quickly ran out of data. And then the researchers very quickly started getting very big bills for the data from the mobile phone providers, because this eagle was flying across multiple borders, and obviously, using a Russian cell phone in Kazakhstan and then in China was going to cost them a lot of money for data. So you've got to rethink about these things. The final one that I came from my list was something called LP1, which really excited me. This is the project in Birmingham mentioned uses LP1. It's based on the same technology as mobile phone data, as cellular data, but it's low powered. It's quite slow, so it's used for just sending a little bit of data here and there. But it's a lot cheaper. It's actually got a really, really good range. So the important thing to think about is actually when you're connecting your IoT devices, and I understand you all starting to think about the projects that you're going to be designing and possibly building, but certainly designing, and coming up with the right kind of idea to be able to do this is really important, because choosing the right connectivity can make or break a project plan. If you choose the wrong thing, it could make your project non-viable. So that's the info over. What we're going to look at now is actually let's make something. That's the fun bit. That's why people are here, is to make something. So I'm going to really quickly take you through using the emulator to build a circuit, and then I'm going to send you to a link which is going to take you through a step-by-step tutorial. So this is a method I've used with the students over the years, so you guys can all work at your own speed. You don't have to try and keep up with me. And I've produced that tutorial in a video, so you can play and pause as you want, as a PowerPoint or as a PDF. So you can use the technology that works for you. But first thing, I'm going to show you a really quick little demonstration, as long as I can find the right window on my many computers. I'm going to open a new one. I will come over here. So I think it's a bit slow. I think my computer doesn't like the temperature. So we're going to use a website called Tinkercad. Now I did have a video sent out, but I understand that it came to you guys a bit late. So Tinkercad is completely free, but you need to log into it. And the video is just literally a very quick getting started. The easiest way to do it actually is if you join now, you can actually join with a Google account. So I'm just going to sign in with my existing account, which is a Google account. It takes me straight in. Now, a colleague of mine introduced Tinkercad to me, and I've fallen in love with this website, because there's so many things you can do. You can design circuits, you can actually run the code in the circuits, but you can also do 3D modeling in there as well. So it's got loads and loads of different things, and it's a professional level kit created by Autodesk. Thank you, Keith, I appreciate that. So we click on this. I'm going to create a new one, and I'm not expecting you guys to keep up with me here. It's just a demonstration to show you how the bits work. And of course, everything's going a little bit slow now. So we can search for what we want. So it's an Arduino. So I can put my little link in there. There's my Arduino. I'm going to stick that on. And just drag and drop things over. I need a breadboard. So we use breadboards for what we call prototyping. And what that means is we can build our circuits and just plug the wires in. and we don't need to worry about soldering things and getting the wire all connected correctly. It's really clever. So these columns are joined up acrosswards, so that's joined up, that's joined up. Same thing over here, but you've got a gap in the middle. So you can put your components in, plug them into the pinholes. If you've got two across there, for example, those components will actually be joined together electrically, and if you go crosswards, they'll be separate, so you can then connect them to other things. So it's a really, really clever little piece of kit, and it saves a lot of energy. We're going to put an LED in. I'm going to plonk that on there, and you can see, so I've now got the cathode, I've got the anode, which is the two ends of the LED, because it is directional, and I can just connect that with a cable. So I need a ground cable, which is the negative, so I'll click on ground, just drag a line over to the same columns as that, drop it in. I like to make them black so we know it's ground. And what you can do is you can just double click, make a handle, and you can make your wires look nice and neat. We need these LEDs. If you put too much electricity in them, they've got a tendency to blow up, as I found out in a school with a very sensitive smoke alarm. So what we do is we put a resistor before it, and you can change the resistor. So a good tendency is 220 ohms. And what that does, it's a bit like, if you think of electricity being like water running through a hose pipe, it's a bit like squeezing that hose pipe. You're just slowing down the amount that's getting there, and it stops things blowing up, which is generally a good idea. But the Arduino's got all these pins. So with number here from 0 up to 13, they were called digital pins. So you can set a set range of values, and they're discrete. So you can set it to 1, 2, or 3, but it is a specific value. We've also got analog pins that we're going to use later on, and that's a continuous range. So we need to think about analog and digital and decide which one we're going to do. I'm going to drag another cable from pin 7 down to the bottom of that resistor. Because that's going to take electricity from the positive, I'm going to make it red. And again, I can just make it a little bit neater if I want to, just to tidy this up. So what we're going to do, I'm just going to make the voltage coming out of the pin 7 high. That'll flow through, turn the LED on, goes back to ground. We'll wait a moment, then we'll turn it to be a low voltage. So we'll go to our code, change to text, and say continue. And I have to make a few changes. Let's put the basic program in, which is quite nice. So I'm not using pin 13, I'm using pin 7. So I'm going to change the 13 to 7 there. We'll say we're going to take pin 7 high, so it's going to be high voltage. Wait for a second, 1000 milliseconds. It's low. Wait for 1000 milliseconds again, and then we loop around and around and around. What I can do, I can press start. And what you can hopefully now see on your screen is the LED flashes on for a second, and off for a second, and on and off. And that's as simple as the circuit can be. So, now you've seen me do it really quickly on the screen. I'm just going to flick back to the presentation. There we go. And we're going to do something, and I say we because I'm going to send you guys the link for the tutorial, but I'm going to do it on the screen. And while you guys are working through the tutorial, there's a few things you need to be aware. First of all, feel free to pop up and ask a question, because it's a learning process. If you need to ask a question, please do so. The other thing to think about is actually, I don't care whether we get these things right first time or not. Remember, my background is as a teacher. I don't really care about students getting things right. It's when you get a problem, figure out how to solve the problem. That's the important part of learning. Because if you know everything already, there's no point in learning because you already know it. So it's making the mistakes that's important, figuring out how to fix those mistakes. So what I'm going to do is, when you're working through this, when you make a mistake, try and figure it out. If you can't, feel free to come speak to me, not a problem, but try and figure it out. And keep notes of that, because at the end I'm going to test you on it in an ideal way. And now I'm going to give us around about, I think probably 25 minutes to work through this, and then we'll come back and we'll talk over it. So the link I'm going to send you to, I can't actually copy from that page. I'm going to have to get it from somewhere else, so I apologise. I'll put this in the chat in just a moment. I'm just going to put the link in the chat window. And that's a really, really simple little web page. It's just got a link to the walkthrough as a PowerPoint, a link to the walkthrough as a PDF, and it's got the embedded YouTube video as well. So I do encourage you to go through, use the method that works for you guys, get started on it, get into Tinkercad and start playing with it. But please, as I say, do pop up with messages, and I will respond as quickly as I can to as many as I can. And I'm going to build that through at the same time as you, so we can all make the same mistakes together. I'm going to give 25 minutes, Patricia, but we can come back early if we need to.
Oh, thanks for answering that, Keith. Oli, Patricia was asking how long do you have?
Yes, I'm going to say about 25 minutes, but we'll see how things go. Because if people want finished early, I've put some extension bits in there as well. But if people are finished early, we can have a chat about what people have learned, and we've got some extra we can do as well. So it really is down to the people that are engaging this and how long they feel they need. Gabriel, you need to create an account, but if you've got a Google account, it'll just link to that straight away. So as you can see, I've circuits over the development of this webinar. So I'm going to create a new one. I'm just going to talk away as I'm going through this, and hopefully we'll be in a similar kind of place. So we'll scroll down. We need an Arduino. I need a Blackboard. Okay, so we need our LED. I've used a photoresistor. So what this does is it actually looks at the amount of light coming into it, and it increases the amount of resistance. So again, like the hose pipe, kind of squeezes tighter and tighter with more light coming into it. So it's quite a simple little sensor that I'm sure that some of you have seen in previous seminars. But it's a really simple device to be able to measure the amount of light coming in. Okay, so we'll do resistor for our LED. That's 220 ohms. We'll go. So we'll just go for ground there. Oops. I also think it's really worthwhile spending a bit of time to tidy up the wires in the circuit. It just makes it a little bit easier when things are going wrong to figure out what might have misconnected. There's a live cable from the LED to, I can't remember which one I used now. Set number 4. And what I always think is worthwhile, you said I've been studying computer science for so long. One of our favourite things, it's the word decomposition, break a problem down into bits. I always think it's worth, when you've got a bit of something done, is to test it out. So I'm just going to give this a quick test and make sure that my LED is working. So again, we can just change that to use the right pin number. Or we can test that out. Why was that the case? I'll try and open up a new window and get back to show you. Yeah, it's these columns. It really does save time. It took me a while when I first started playing these. I was obviously they don't come with an instruction manual. I couldn't figure out what was going on. So each of these columns, and you can see it just highlights a green when I hover over a pin. So each of those columns is connected up with a little bit of copper underneath. So it just saves you having to connect too many wires together. So Emma, so I've just come back into the dashboard here. So hopefully it should say on the left-hand side, there should be circuits on the left. And we're going to go to that and then create a new circuit. Great, excellent news. Okay, I'm going to pause a minute and just let that flash away while people kind of catch up. So obviously, I've built the circuit a few times recently to make sure I know what I'm doing, so I'm probably going a lot faster than other people. Excellent, Dan. The first time I ever did that on a real Arduino was such a sense of achievement. I should have warned you this beforehand, though. It can be a bit addictive. I found there's a company called RS Components that can deliver next day, and I've got so many different bags of little microprocessors and resistors and LEDs floating around now. It's costing me a fortune, so apologies for that if you get too addicted to it. Right, so I think I'm going to try and remember how to do the rest of this now. So what I'm going to do, I'm going to connect up the one end of that resistor. Oh, actually, I think I need another resistor here, don't I? So what you can do, you can connect your device over the gap. So obviously you need to have a gap between the two ends of each component, else it doesn't do anything. Another thing you can do is actually you can rotate it around. So you can then jump across columns, which can be quite a nice way of doing things. And just don't ruin your breadboard. So we'll connect that there. So the circuit now goes in one side, in there, and then out the other end of the resistor. And that resistor there, this one I'm going to make it into what we call a 10 kilo ohm. Oh. I fully understand you. Sorry, I'm just going to go to Gabriel just briefly. The rotate button's up here in the top left, Gabriel. So you just click the item, and then you just rotate around as much as you like. It only goes one direction, so if you go too far, you have to go all the way around again now. Jude, just looking at your comment there, that's quite common. When I was teaching, I used to, obviously I got to know my students, and I'd print things out in advance for them, or even give them separate screens. That's a real shame. I've not got a netbook to try it on, I'm afraid. I know people have used this on Chromebooks, but maybe it's just the Blackboard and Tinkercad at the same time. That's great, Dan. It's a great little tip. Like I say, I'm quite new to the emulator myself, so it's great to learn these things. So fantastic news. I've lost where I was. Okay, so this resistor connects to the photoresistor. Changing the code again, please. Sorry, yes, of course, we come back. So we go to the code. I'm there to open up the code. This starts with 13. And 13 is every Arduino, well, most Arduinos got a built-in LED, which is connected to pin number 13. So all we need to do is just change the number to whatever you've connected to. So I connected mine to pin 4, D4 there. So I just changed the numbers there. I just changed 13 to 4, 13 to 4, 13 to 4, and then first start simulation. Excellent, great, Mark. I'm glad it's solved. And yes, Emma, the website that I linked earlier on is that's my website, and these are going to stay there, so they'll be there for as long as you ever want them. You can run through them as much as you like. And I've put some other tutorials up on the website as well when I've been learning new stuff recently. So feel free to have a browse at your leisure as well if you want to. So this, what we do here, we connect an earth again to this one. And the Arduinos have generally got a few earth connections on. So I'm going to click to this one over here. If, when you're developing your own circuits, if you find you haven't got enough earth connections on the Arduino, what people tend to do is you'll connect earth to one of these black lines at the top and the bottom, and you can actually jump between the two if you need to. People tend to do the same thing with the positive 5 volt or 3.3 volts to the red lines. And then you can just pick up an earth or power connection whenever you need to. I didn't really want to make things too complex for your first circuits though. So we've got an earth connector, we've got a power connection going into this side, so we're going to use 5 volts going into the other side of the photoresistor. And power again, we normally use red. I'm just going to make that a bit neater. And I love how I get these lines nicely lined up and just looking really smart. So what happens at the moment is the power will run out of the 5 volts. It goes through the photoresistor, and either lots or little or a medium amount of electricity will get through, depending on how bright the light is shining into the resistor. And then pretty much all of it gets stopped by this big 10K resistor here. And that stops electricity because it then runs back through to ground. So that's something we call a pull-down resistor. And what that does is it means that when we've got a signal flowing, if you don't put it in there, sometimes it can do what's called floating, and then you get some weird readings depending on what's happening nearby. So that pulls it down to earth, and it means that it'll just flatten any problems out. And then we're going to use another one. We're going to use a signal wire, and that's going to go from here, and we're going to go into one of these analogs. So we're going to analog 0. And I quite like to use green for a signal wire, because that's actually going to tell us how much current is getting let through that photoresistor. So we've got 3 wires running to that now. And that there is the circuit completed. So again, I'm going to pause a bit. I'm going to leave that on the screen to let people try and get caught up to where we are. So just to remind you, this, and it's not massively important for this circuit, but when you get a bit more complex, choosing the right resistor can make a big difference. So this one is a 220 ohm being named after the gentleman that did a lot of work about resistance of electrical circuits. So that's 220 ohms. So that just stops enough to stop our LED setting on fire and setting off the school fire alarms, which again I wish I'd known a few years ago. And this one's a 10 kilo ohms. So that's 10,000 ohms. So that's actually quite a decent amount of current in that one. So as and when people either get the or get to the state where they're moving on to writing some more code, if you can just let me know in the chat window, because obviously I'm used to be able to see how people are doing, and I can't see how you guys are. So if you just give me an update at some point in the chat window, whether you're doing well or whether you're getting stuck or whether you're moving on, that'd be fantastic. Great, thank you, Mark. Well, need to finish my code. Sam, is that the first code for the LED or the main code? So the horizontal, the main code. Samuel, you're going to embarrass me here. I have put a challenge at the end though, so hopefully you'll keep me going there. So for rotating the resistor, we can just drag one on, and you can just press the R button, and that'll rotate it around, or you can use this button here in the top left. Robert and Aaron, I could send the code in the chat. Is it because you were unable to read it, or because you don't want to write it? That's a very good point from Samuel. Interesting, I didn't notice that, to be honest with you. Interesting that it worked in the simulator. So I wonder if maybe it's something that they've not done right in the simulator either. But it's easy enough to move that over to a PWM pin. And we can just flick it over there. So Robin and Aaron, what I will do, I'll paste the code into the link, the website that we mentioned earlier. However, yes, I'll do that. Please, thank you. However, I suggest people type in code rather than copy and pasting, and that's from years of teaching people computer science. I find that you tend to pick up what you're doing better if you write it yourself. Gabriel, no, so the blink code, the one that makes the LED code, the LED flash, is the kind of the basic getting started code. So it puts that in for you automatically. The rest of it does expect you to type, I'm afraid. I'm just going to go in and quickly put this code into the website for you guys, and I'll update that as I go as well. That's the assuming you mean this bit here. That's a reset button, I believe. I'm just trying to look on the real look. Yeah, that's a reset button. So I'm just working on putting that code into the website for you, but my Tinkercad's only going very, very slow. Okay, so for anybody that wants the code, I've just put that at the bottom of the website. You'll need to refresh it, but it should pop up for you fairly quickly. Hopefully the formatting looks okay as well. Okay, so I'm going to give you, I know Samuel's doing piezo stuff, which is fantastic. It does get quite loud, I'm afraid, Samuel. But I'll give you guys probably another 3 or 4 minutes. Then we'll come back and just see where people have, how people have done, how they've got to before we move on. So the code I wrote, because obviously I've not put that in here. Let's just paste that into the see actually working as well. So hopefully you should be able to see in my screen. It's a bit slow to respond, but you should be able to see that when down here we've got no light getting the LED brightens up, and over here it just gets a bit dimmer. That's quite a satisfying little project. Yes. And what I did notice is even when you go right down as far as the resistor will go, it's still quite loud. It doesn't really have a quiet mode. I think probably it could do with having a resistor in there of some kind as well. But I just wanted to put a little bit something else there for you to be thinking about, really, Samuel, rather than teaching you whole new elements of theory. But yeah, I was quite surprised, and my daughter was working next to me when I played that earlier on, and she jumped about 5 feet out of the chair when I pressed go and started buzzing herself. Sorry, everything I ever deliver, Samuel, should come with some sort of health and safety warning, because this is the kind of thing that happens. If you can think how amusing it is when it happens to one person, it's even funny when you've got a class of 30, 14-year-olds and they all start jumping up and down because they've all got headsets on with buzzing piezo. So it can be quite good fun. What else have I done? I've smashed a few monitors by throwing things across rooms a little bit too energetically, so that went down too well with the people that hold the purse strings. What else have I done? I mean, the LED wasn't my only smoke hazard, to be honest with you. I took an Amiga 500 into school that hadn't run for a few years, and the power supply set on fire when we first turned it on. So that was quite an interesting one. Yes, it's amazing they ever let me back in the classroom, to be honest with you. I've never really broken a child though, and that's an achievement I'm quite proud of. Okay, so I'll give you guys just another minute to finish off whichever bit you're on at the moment, and then we'll come back and see how things are going. Really quick recap. Yeah, I'll do the best I can. So, Zubia, nice to meet you. What we've been doing. Thanks, Sammy. I'll have a look into that. I've never really played with piezos before, so I'll have a look at that. So, Zubia, what we've been doing, I gave a quick talk about some of the things I found out about the different ways that that IoT devices can communicate with the internet or with other devices. And then what we've been doing, we've been building a circuit, really simple little circuit, which you can see on the screen now. what this does is we've got a photoresistor. So as it adjusts the amount of light coming into it, that then comes down this green signal wire here to the Arduino. The Arduino reads that, does a little bit of math to try and get things the other way around, and then it sends out a varying voltage to the LED to make it more or less bright. The idea is that as things get darker, your lights can get brighter, so you can still see whatever you're doing. And all this is really is it's a first introduction to the Arduino, to hopefully give you guys some ideas to what you can do and how simple it is to get things to work, for the kind of the projects that you guys are thinking about putting together. And really, I mean, they're tremendously clever things, and I'm by no means an electronics expert. I've built a fair few circuits, but then when I send them to my experts, they then teach me what you get from doing electronic engineering for decades. But what I have found out is that by using an emulator like this or some cheap electronics, you can make some wonderful things happen quite simply. Please be your service. Okay, so guys, let's I'm going to stop my simulation. What I like about this is when you stop it, they unplug the USB cable, which I think is quite nice. It can be quite complicated, but one of the tricks is that you really do need to break it down. You need to do a little bit at a time. So the first thing I did was get the LED flashing. And to be honest with you, if I'd missed out the resistor there for that LED, because it's an emulator, it would have worked as well. And quite possibly even to, I'm not sure, but it might even work with the resistor, the photoresistor as well. I didn't try it without that, but the thing is to do a little bit at a time, get that working, and then build upon it. But I was talking to Richard earlier on, and to be honest with you, it doesn't matter if things don't work. You know, we're not just looking for a perfectly working device or a perfectly working concept. We're looking for ideas and dreams. And it doesn't matter if it doesn't work first time, 10th time, or ever. It's about thinking about what could we do? What could we do? What could we think about developing? That's a really interesting question. There are various rules you can follow. There's various things you can try. What I did with the LED is I changed that to something really small. I think it was like with 10. And when I ran it, and it took a while, it popped up a little message there saying, "Oh, hang on a second, you've got too much power going through there." The LED is 22.3 milliamps, but we suggest you only use 20 milliamps. So what that can do is it can reduce the lifetime, and I found out once it can reduce it quite significantly. So I thought, okay, well, I'll change that up and I'll make it I'll make it 100, and I tried it again, and it went away. So you can actually do some, you know, it's quite clever. It tells you things like that. And there's other rules about which one you use for the pull-down resistors. But a general good rule of thumb is 220 ohm resistor for an LED will generally be okay. It doesn't dim it too much, and it definitely stops enough power. I think that even works if you use a bit more than 5 volts. And for a pull-down resistor, a 10 kilo is generally a good start. And I've built, my webcam's not working on that, I've got a couple of circuits I could show you on my desk. And it's just built out of bunches and bunches of 220 ohm resistors. And that's, you know, they're generally a good, if that's all you've got, they're good enough. But the idea is you try a bit, and if you're not getting enough power through, try something a bit smaller and see what works. But it doesn't matter if, I mean, these are, I'm not an electronic engineer ever. These are just things I've picked up when I've been playing with these things. Serhan, I think it's probably best if Richard answers that one, but my interpretation is yes. We either of those is good. Gabriel, I'm a bit of both. I love developing, but I do even more love making things fail in real life. And like I say, you know, these things are so cheap. And I got an Arduino Nano, a little Diddy one, for eBay for about £3.50 for the week. And you know, if I blow that up, I don't really care because it's £3.50. Richard, are you able to jump in and answer Serhan's question while I just flip back to the
absolutely, Oli. Sorry, I was just waiting for you to finish. Serhan, yeah, absolutely. Just please do, you know, any idea you've got, as Oli was saying, and as Keisha was saying, and as Tanya was saying, it's all about just giving it a go, really. And we're just looking for ideas that are using IoT to solve a problem. So that could be a huge thing, or a small one. So, we're really, we're really excited about getting all your different kind of ideas that, are all types. Some of them with really big ideas, and some of them just doing exactly what we're doing now. That Oli's doing now is using a circuit. Like Tanya showed you her plant that she had the moisture sensor in. So anything from there to a big idea. And I noticed Oli was talking about earlier today using, the Internet of Things, using kind of things like a sensor for road temperature. Which in a way is a kind of big idea, and as Oli said, saved an absolute, load of money to the road builders. But then again, is just a circuit, as Oli was explaining before.
What was now in number 2? I've put the code at the bottom of that web page, so if you do want to just copy and paste, you can do. I mean, it's not the method I suggest. I don't think you learn as much that way, but if you want to just get it working, just give that a go. So, I mean, really, I wanted to spend a bit of time looking at what mistakes we've made, but we are running out of time. One thing I found really exciting that I learned is the chap that developed this these devices for the road temperature in Birmingham. He then set up a kind of sister company, and they were using it on rail tracks. And it turns out that when there's leaves falling up, we hear, oh, the trains are all running like leaves on the track. Leaves don't cause a train a problem. What it does do is it holds moisture on the track, and then when they try and brake for the stations, the trains just slide straight past the stations. And this is why our trains were late, because of leaves on the track. And he developed these, again, IoT sensors using the LP1. And what it does is it measures the amount of moisture at particular points compared to the time of the year to figure out how many leaves is likely to be on the track. And then they feed that back into the control room to tell the train drivers need to start slowing down earlier. I thought that's wonderful. I mean, I've not yet seen the advantage because my trains are still always late, but it's a wonderful use of IoT. And again, these things are costing, between 10 and 40 quid a device, as opposed to having to pay a person to drive up and down all day looking at how many leaves there are. It's a massive saving for them. So we do have a second session coming up next week. And what I'd like to do, I know I've said homework, and it's because I'm a teacher, I'm sorry. But really, what I want you guys to be doing is thinking, well, have a look around you, look at the kind of cool IoT devices that you can see out there. And can you see any that might be running on an Arduino or something similar? Can you see, we mentioned analog and digital inputs and outputs earlier. And I'm really, really appreciative that somebody pulled me up on a mistake. And the weird thing is, like I say, it still worked to a certain extent. So there's obviously something weird going on there, but it's great that you pointed that out to me, because I'd obviously missed the tilde on there. Probably because my eyesight's all, it's 35 degrees in my garage. So have a look around you, have a look online or in real life. Websites such as instructables.com, which I'll put into the chat. Are fantastic, there's loads of examples on there. I just want to have a look around and start getting some inspiration. Can you see the kind of thing that could be running on an Arduino? And can you see the difference between these analog and digital inputs and outputs? Because actually that makes a big difference to what you're doing as well. And from that, I mean, that's pretty much it for me for this session. We've we've run right up until 3 o'clock. I was hoping to have a bit more time to chat, but I've spent too much time talking. I apologise. But it's been really, really interesting seeing some of the comments you guys have made. And I'd love, I mean, obviously, I've sent you a link to my website with this information on. And if anyone does fancy having a chat, like I love learning. So I'm more than happy to have a chat via Twitter or via email or chat or whatever. And just share some of your own learning as well, because it's really, really interesting for me. But thank you very much for your patience, and I'll pass back over to Richard.
So Richard, it's Trish here. So thanks, Oli. I just wanted, there was a couple of things. One thing I was going to say, were we thinking of setting up sort of a Slack channel for people to join, so there could be some discussions?
Yeah, that's a good idea.
I think that might help. And the other thing is, I just wanted to say, so about creating your IoT system, design, device, intervention. So even if you take something like watering the plant IoT device, and even though that already exists, one of the things is to think about what impact, what change could you do that was different with say, a device that's watering the plant, that you feel would help improve the environment. So it can be the same idea but applied in different ways. So it doesn't have to be something massive, and it's also about your exploration about why you think IoT brings a change to the environment. It's not about creating these very complicated and quite sort of systems that probably require large groups and a lot of time. It's really about your problem solving and thinking about your design, and you can use things that already exist and apply those, and you may not have all the technical things available, so you can also look beyond that as well, and just about what would the design look like and tell us that story. And I think we're going to work on a form to help guide people through that a bit later as well. I think we're going to try and do that, Richard, won't we? We're going to try and put something together, I think, for that.
Indeed, yeah. So,
yeah.
as I was saying before, that we'll have a form up there next week, and so everyone can fill it out then if they're joining the challenge. As Trish says, make us a video, anything on your phone, or draw it out. It's just really kind of really interesting ideas. And as Trish said, we're really looking just to see how you can think of solving a problem out there. And it's just, you don't have to build a really huge complex circuit. You can pick one if you want, but it's just kind of using IoT type ideas. And as Oli was talking about earlier, just that you've got the connectivity is really important to think about, and then what things. So, literally, if you break it down, Internet of Things, and you might look at how the connectivity between the things and the internet, and then what actual things you're using. So it's just kind of using the Internet of Things and making of kind of ideas about how you might solve problems out there in the environment, which is your environment, meaning your own house, your own life, or the kind of something that tries to help the planet.
And just to follow on also with using the emulator, so if you don't have any, and you're enjoying having fun with the emulator, and you don't have any bits and pieces, hardware, don't worry. And if you want to build something in the emulator, and then think about how it would connect, like how you connect data together, and you would just design that as a as a storyboard and explain how that would work as well. And if you don't feel comfortable with the emulator and you want to just design your new device and your new way of doing the Internet of Things, that's equally valuable, and explaining how that might sit together. And they're very interesting, because getting diverse thoughts and inputs is really useful to this. So it's really, as Richard was saying, we're putting these resources together to help you think about it, and perhaps be able to use and explore those. But it's really about thinking about the problem solving and how you want to make a difference in the environment.
Well, thanks everyone. That seems to be it. You don't seem to have any more questions, so thanks a lot. If anyone hasn't done the questionnaire, please take a moment to do it. That would be really helpful for us. Oli, as you know, is back next Tuesday, I think, and we'll also be around on that Wednesday session we've got, when we've got kind of an open community on Wednesday, and we've got some experts on hand for answering questions. And as I said before, on Monday, apologies, but we've had to cancel the session, but we will have it open if you'd like to just kind of use the room to chat with other participants, or a couple of us will be in the background, me without too much IoT knowledge and Michael with a bit more, and hopefully we'll be able to answer any questions you've got. Thanks, Sohan, that's really kind of you.
Richard, you got a question from Zoe there.
So you submit your materials. You don't need to present them on the 3rd. Your video, whatever it is. Of course, we're around for questions and to support you throughout the whole of the process. Any questions that come up during that time, and if you want to ask us anything further, that'll be fine. I don't know, Richard, if you want to ask anything else about that. sorry, add anything else more about that?
No, we'll you know, obviously we'll let you know, and we'll be putting more up on the website next week. But yeah, you do not have to present. Don't worry, Zubia. We're absolutely quite happy. However you'd like to. If anyone would like to present, they're more than welcome to. But generally, yeah, you could post a video, and Michael can help you nearer the time with how you might do all that. But we'll have lots on the website next week anyway to say how you actually do it.